Hey everybody, Mr. Kirkwald here, back again. We're starting a new unit today. Our new unit today is going to be all about sounds. We're going to spend about 2 weeks here on sound, then 2 weeks on light, and then I think that's about it. So today I want to start out just getting some vocabulary down and just kind of going through the basics of sound. A lot of this stuff, we're going to watch some YouTube videos about some cool stuff going on, and then we have a reading assignment in the middle. We've got another set of different YouTube videos that are talking about how sound looks, and then next week we'll get into some more stuff. So I'm going to scroll down here, distance learning, May 11th through the 15th, that's this week. You'll notice one folder above mine, so you're already in the May 11th folder, but you may have been like, what in the world is this? So if you watched earlier, Miss Mizuka made some awesome videos about sound, and so I would recommend going in and watching those. But part of that is watching sound kind of dance on her wall. So we'll talk about this more a little bit later, but there's some awesome songs in here that she did. Highly recommend. Baby Shark is in there. There's some cool ones. So I would recommend just checking that out in your own free time, but you do not have to. So today, May 11th, we're going to go into sound notes. So when you open up sound notes, it looks like this. And then as I'm talking or as I have stuff on the screen, I want you to either move or type that. So you're going to pause. Remember, we did the half screen, so you moved your screen so that you could just have half of it over here and the other half over there so they could watch both at the same time. We're going to do that same thing today. So today's essential question on slide 2, what is sound? So we know it's a couple of things here. We know that it's a mechanical longitudinal wave. So a mechanical wave means that it has to have something to move through. So sound can move through solids, liquids, or gases. We typically think about sound with gases, but it's also longitudinal, meaning it runs parallel. It's that compression expansion. So it's like the slinky when we were pushing it. If you watch the video with me and my son, when we pushed that, the slinky got closer together and further apart, closer together and further apart. That's how sound waves work. The molecules keep bouncing into each other until they get to your ear. So we also know that sound works in the ear, that it's about hearing and noises. We know about music with sound. We know that it's a form of energy. And then we know that it has to travel through a medium. It has to travel through something. Sound cannot travel through empty space. So when they blow up the Death Star at the end of Star Wars, spoiler, when they do that, there's not actually any sound happening because there's no molecules out there to run into each other. So it's just a really eerie, silent explosion. So we've got a lot of vocabulary words. So I've got a bunch here. I've got some pictures that go along with them too, and then we'll just kind of explain them. So we've got our jumbled up mess, just like usual here, and then we're going to sort it out. So the first one here is I'm going to choose loudness. That one makes the most sense to me. So I'm going to move pitch out of the way. I'm going to put loudness over here. So loudness is the measure of how well a sound can be heard. So if you can hear it really well, it's probably loud. If you can't hear it very well, it's probably not very loud. Okay. The next one here I want to talk about is pitch. So pitch is how high or low you think that sound is. So if you think it's super high, I'm not going to sing for you because that would be super embarrassing. But if you think it's super high, then that pitch would be higher. If you think it's super low, then the pitch would be lower. Okay? And then the last little one here has to do with loudness. That's decibel. A decibel is a unit of measure. So if you've ever heard about like football stadiums, when football stadiums are like, we're at 130 decibels, you know, that it's a measure of how loud that sound is. And then I think there's a picture later that we're going to talk about with that. The last word here is called the Doppler effect. I'll just leave the definition here, so I just want you to have it. We'll come back to that in a little bit when I've got some pictures that go along with it. So loudness, how well the sound can be heard. Pitch, how high or low you think the sound is. And then we'll talk about the Doppler effect and decibels a little bit more here. So when we're talking about pitch and loudness, loudness is all about amplitude. So remember on our sound wave, like if you look at these ones here, these little ones here, not very loud. Okay, as they get bigger, or like this blue one way over here, that one is huge. Okay, since it's huge, that means it's louder than these little ones. So loudness has all to do with amplitude. It's how much energy is in that wave. So amplitude shows us a lot of energy in the wave. Our other word here is pitch. So pitch, instead of amplitude, pitch is the frequency of the wave. It's how quickly those waves are coming together. So this depends on the frequency and wavelength uh, of a sound wave. So we need a lot of those things in order to take a look at pitch. So pitch is all about frequency, how close those waves are together. Loudness is all about amplitude, how big those waves are. So on slide 5 now, on slide 5, if we take a look, decibel, I talked about this decibel chart that's going to be coming our way. So decibel, if you look at this chart, I know it's a little bit small. You can make it a little bit bigger to have it go up. The dB goes over here too. Decibels, typical sound levels. If you take a look at here, 0 is the threshold of hearing. So if that's something, if it's below, it can't be below 0 because that's the furthest that we can do. If you're in a completely silent room, that's still 20 decibels. Okay, so it starts to get increasing more and more. If somebody's whispering to you from 3 feet away or 5 feet away, that's about 40 decibels. If you're having a regular conversation, that's about 60 decibels. Classroom chatter, I always laugh at this one because 70 decibels, I feel like my classroom might be closer to 90, but that's just it. Freight train, this is without the horn, so this is just the train going by, so not the train horn. That's 80 decibels. A boiler room, so if you walk down to where Rick is and started listening in there, 90 decibels if it's really going good. Then construction sites are 100. Nightclubs, that super pumped up music is only 110. And then that's where it starts to get really, really, really bad for your ears. Anything over 100 decibels, not great. So when you're operating heavy equipment, 120, or a jet taking off, if you go and Google like the loudest stadium ever, I feel like it's close. I want to say it's over 120 decibels, something like that. That's really loud and not so great for your ears either. The other word here is Doppler effect. I don't know why it's so small. We'll make it a little bit bigger. So Doppler effect here. Doppler effect is all about police sirens. As a police car is going past you, think about it. As it's far away, you hear whoo, ooh, and then as it gets closer to you, it gets higher and higher pitched. Now, some of you might be thinking, well, yeah, it's because it's like a siren that's like doing different pitches all the way across, and that for the most part isn't really the case. What's happening here is something called the Doppler effect. So as in our little picture here, as something is right next to you, the frequency, okay, of those waves are really close together. But as it gets further away, look at the gaps that are forming over here. So the frequency gets lower. So if you think about pitch, pitch is frequency. So pitch is all about the high or lowness of that sound. So when we're talking about the Doppler effect, we're talking about those police sirens that are close to you sound higher pitch, and if they're further away from you, it sounds like a lower pitch because of that sound wave, the frequency getting further and further apart. The next 2 slides I just did for you, so you're welcome. Slide 6 is about resonance. We'll watch a video on resonance later. This is what happens when a sound wave matches the natural frequency of an object. So tomorrow you're going to watch some videos about the natural frequency of like the human eye and those kinds of things. So there's some cool stuff there. But if you pump a sound in at the exact frequency that that object is in, then things like breaking the glass, or over here, this weird sand thing, it's called a Chladni figure. We'll watch a video about those a little bit later too. Those are super cool. And then, yeah. So resonance, just keep it in mind and we'll come back to that one. I just wanted you to have all the vocab in one place. Slide 7, does sound move faster in solids or air? Stop, think about it, don't look at the bottom. Oh, you already looked at the bottom, come on. So, does it move faster in solids or in air? And the actual truth is that down here, sound waves travel faster through solids because those molecules are closer together. I want you to think about it. This is the activity we usually do in the classroom. You could do it if you have got other people in the house and you want to push them around a little. So if I line up 10 sixth graders, okay, and I space them out like air molecules, because remember, air molecules aren't touching each other. So if I space them out across the room and I push one, and then they go and push the next one and the next one and the next one, it's going to take them a while to get all the way across the room. But if I line up a whole bunch of sixth graders and they're all shoulder to shoulder and I shove one, well, immediately the next one is going to be shoved in the next one and the next one and the next one and the next one. So when we're talking about sound, sound is actually going to move faster through a solid because those molecules are closer together. So something cool, something to keep in mind. Last thing here is that these last 3 slides we're going to take a look at tomorrow. If you want to preview them today, you can, but then there's going to be a discussion post that goes with tomorrow's activity. So if you want to preview slides 8, 9, and 10, you certainly can. Otherwise, feel free to just wait until tomorrow and we will go over it then. I know that was a lot of information. We're going to be spending 2 weeks here on sound, so don't feel overwhelmed with all of the vocabulary. We will be diving into them a little bit more in these in the reading assignment and in the YouTube stuff. So let me know if you have any questions, but sound notes. That's it for today. If you got that done, you're good to go for science. I will see you guys later.